The results that we find shows that the analysis during the descent phase shows the lats, pec major, delts, and triceps produce continuously higher bioelectric signals, the highest being from pec major, as the load increased during the descent. So more weight, more muscle activity. The largest difference was found between the 70% and 100% loads. So the lowest load tested and the highest load tested. Bar speed, bar path were consistent between all loading groups and had no correlation to the load, and show that they're pretty consistent between the 70, 80, 90%, 100%. As we move through this review, the analysis will specifically be on the effects and correlations measured during the ascent phase. And very similar to the descent phase, the total mean EMG data shows a strong positive correlation with barbell weight. Higher the weight, the higher the EMG data. However, the data shows that only the lats, front delts, and triceps show a significant effect between the loading groups. The largest difference, again, was found between the 70 and 100% loads. However, pec major had no statistically significant correlation between loading groups. This, of course, it did not mean it did not produce force, but the force generated was consistent regardless of the studied loads. However, this statistic doesn't tell the whole story. As soon as the bar comes off the chest, pec major activity falls off a cliff and doesn't recover until about 50% of the ascent is completed, so about 15 centimeters. So where does the force needed to move the bar come from? Well, based on the data, we see a huge spike in tricep, lats, and front delt activity during the first quarter of the lift to take up the slack from the pec major. The pec major actually downgrades its contribution as a prime mover on the 100% of 1RM, and the triceps continue to surge with a higher EMG compared to any other muscle in each loading condition. The hypothesis that to stabilize the lateral movement of the bar, so side to side, pec major becomes as the authors call it, a quasi-prime mover stabilizer.